This is our robot cross, and I'm just going to explain all the different parts of the robot and what they do. To start off, you have inputs and outputs. Inputs are like sensors, stuff that puts information into the brain of the robot, which is this. Then you have outputs, which is the brain sending out information and telling something to do something, which would be like the wheels. So the wheels are outputs. They obviously tell the robot to go. In order for us to be able to do 0-point turns, which would be that would be a 0-point turn. We have 2 pivot wheels on the back which slide, so we didn't have to add like a third wheel back there. So this allows us to do 0-point turns. And we have this motor up here. This does a bunch of things for us. This comes up and gets the door and pushes that door. It also throws the ball into the sports mission. It also pushes the slider over here. It pushes it like that and comes back to base. Then we have this. It's a small motor on the left side. This doesn't do anything right now. This is there for in the future when we need it to do some other things. We already have some ideas about that. Then the inputs. These are 2 light sensors. We use the light sensors for consistent starting points going out of base, because there's 3 different ways that the robot can be positioned. Not positioned. Anyways, there's orientation, which is this way, and then side to side, which is this way, and then front and back, which is this way. And going out of base, if you line up with the line, that takes care of 2 of them, which is orientation, and it's also front and back. So then all you have to worry about is the width, lining it up the right way, side to side. And then we have the gyro sensor, which is all the way in there. It's in there. You might not be able to see it. Actually, it might be better to look at it back here. It's in there. And that we use for going straight. We've created a bunch of my blocks that we use the gyro sensor to go straight with. And we also use it for turns. We tell it just to wait till the gyro sensor sees like 90 degrees, and then to stop, and it'll take a 90-degree angle, 90-degree turn, and that's that. And then we have the front bumper, which we use to line up with the wall, and then we have the back bumper, which we use to line up with the wall. And then we also have 2 side bumpers, which we can use to line up sideways with the wall. And our robot, you can really easily change out the batteries. You just pop it off, take this thing off, pop out the battery, put it back in. It's very, very simple. We don't take forever to put the batteries back on. We have a bunch of cables, which we're looking for shorter ones so that there's not as many cables everywhere, but they don't really get in the way of anything, so we just attach them around places, and they're usually fine. Yeah, it's very durable because we had a very great mechanical person down here who spent a lot of time on it, and he made many versions of this robot. We had another one which had a bunch of problems with it. It was too wide, the batteries weren't easily accessible, the gyro sensor wasn't in a good position. There were a bunch of things, and then Sam made a second one which fixed a bunch of the problems, and then Jackson and Jacob and a bunch of other teammates helped him with like attachments, like this attachment. We use this attachment to go up here and get the correct loop. It sticks on the front of the robot like this, and then when it goes up to get it, it just gets it, pulls it back into base. It's very simple, not complicated at all. Our mechanical motto is keep it simple, keep it sturdy, and we try to stick to that as much as we can. We also have this. We only have these 2 attachments. Well, this isn't really attachment. This sits in the front in between the 2 light sensors with 2 humans on it. It's a mission, and you have to push it over here into the circle around here, and that's like 20 or 30 points, I think. And that's not really an attachment, but yeah. is our robot cross. The reason why we called it cross was because in the first version of the robot there were two cross beams at the bottom that crossed like this, and it just kind of stuck. We put two cloaks over the light sensors to kind of protect them and keep the information that was coming in from them more consistent, more reliable, because sometimes lighting is different depending on where you are, and these just help with consistency. We got that idea from another coach who had a bunch of experience with robots. He had a Lego team before, and they got invited to Worlds, so we kind of took his advice. Yeah, that's it.